I'm muted. Hi, we're live. Hello, ETH Denver. Hello, Makerspace, everyone who's watching us on YouTube, Twitch, Twitter. Thanks for watching. I'm super excited to continue with this conversation with Spheroid Universe. This is session 2 after we talked with Andre about augmented reality art in public spaces. We now are moving to talking to the team, the Spheroid Universe team, and the team is going to get hands-on to the nitty-gritty technological aspects, tech aspects of Spheroid. And then we're also going to be talking a little bit about the 10 artists and 10 cities where we are displaying some of the artists from the art project community. An open call that we put together with Spheroid Universe for artists working in the blockchain space, artists who are already tokenizing on 3D, using 3D tools. They submitted some of their work, and throughout the past month, the Spheroid Universe has been working with them very generously to help them achieve the results that you will be seeing today. In this talk, we have about 50 minutes. But we're also taking questions, whether you're seeing this on YouTube or whatever platform you are. Feel free to post your questions. I'm going to bring them to the team as we go. With that being said, I'm just going to give the floor to Andre, the CEO of Spheroid Universe, who's going to give us a brief introduction. And then the guys are going to get talking tech. Welcome.
Yeah, thanks. Thank you, Jessica. Yes, I'm Andre, and I would like for you to meet our team. Jessica, yes, thank you. So Alexey Ostapenko is CTO of Spheroid Universe, who is in charge of developing Spheroid script, programming language, and all the crazy stuff around it. And Sergey is leading visual tech guy who is in charge of computer vision and visual positioning system. He will also describe it in details a bit later in this presentation. And for those of you who just joined our presentation, I would like to talk briefly about augmented reality. What is it? What is all about? And give you some, maybe a few examples of what it looks like. Jessica, could you please show some of the examples of augmented reality objects that are floating in the sky? Yeah, for example, those. So this is the example of augmented reality objects. What is augmented reality? It is basically overlaying virtual objects overlaying the real world. And could you please play several more samples, Jessica? Yeah, thank you. So as you can see, those objects are moving in the real world, and it is different location from the video that was before, and we have a third video as an example. Could you please play it? Yeah, thank you. So these are the artworks that were made by Alexey Andreev, Russian artist, and they were like in two-dimensional shape in the beginning, and then we've met and collaborate with him on creating 3D version of those objects and placing those in augmented reality. And so these were three different locations, and how an artist could place those objects on some particular spot. Well, there are basically two methods. First is when an artist is in that particular space and is placing the objects where he wants or she wants for, to, and but that's usually is a problem because you may want to place it and to show it in some area that is far from you. And if you want to place it in like different countries, like in USA and China, Russia, etc., you won't be really able to move from point to point, and that is why you need to have instruments for remotely placing those objects. And how do we place those objects remotely? Well, first of all, you have to know its geographical coordinates, and knowing those coordinates, you are able to place your virtual objects. Like you can use a map, like a Google map or OpenStreetMap, that's or satellite map that shows the environment around in a photorealistic way, and after you placed these objects, another user that want to view it, so your audience will be able to visualize to view it when they are in the spot that you've placed your objects at. Sorry for my English. And but there is a problem. If you have free space around you, like no large cities, no large buildings around, GPS will return you accurate results. But usually, when you are in the city with the dense buildings, with the buildings near one to each other, that makes signal from satellite to reflect from the buildings, and that leads for augmented reality device for your mobile phone to position itself with a high error rate. Like it could reach up to 10 or 30 or even 50 meters. And that, in some scenarios, that is okay, because if you have a big object and you have some large streets, and it is not a problem if your object is shifting from 10 meters on the left or 10 meters on the right. You can even not see the difference. But when you want your objects to be placed in some particular space over some particular, I don't know, statue, or if you want to centimeters accuracy, you have to use different approach, because GPS won't be able to give you the result, this high accuracy result. And that is what we are in Spheroid Universe is working on. It is called Visual Positioning System. It is based on imagery gathered by our community, and creating and crowdsourcing of creating this imagery database that helps to position AR devices with a very high accuracy. And I would like to for Sergey to continue this presentation and talk a bit about visual positioning system, about how it works, what does it looks like, and maybe we can start from video of Spheroid Earth project, which is about crowdsourcing this data. Jessica, are you able to play it now?
Which
You are muted. Could you repeat?
which video do you want me to play?
One that's 3D development.
Okay.
Yeah, thank you. It is not playing yet, but it will start in a moment, I believe. I truly believe. So this video is about us getting images from a location, and so the set of images that we got from the park, it is park with a statue with a monument inside, and we've made several images of that park, and then we use visual computer vision techniques to make something that is called 3D reconstruction. It is a method of creating 3D map out of two-dimensional photos, and we are ready to show the video with such example. Yes, as you can see on the left, there is a series of photos. In the middle, it's one of photos made, which is selected. And on the right, it is 3D reconstruction. So it is a 3D model created out of series of two-dimensional photos. And that is part of the results that will be part of our imagery database. And Sergey, I would like you to follow this presentation.
As Andrei said, using satellites to acquire your position yields inevitable inaccuracies, which can be, first of all, have a really negative effect on your renderings. To properly render a virtual 3D object, to render it in a realistic way, you also need to account for lighting and materials of the objects around you, which GPS positions wouldn't be enough for. But even further than that, if you try and place a virtual object whose position is tied to a real object in the real world, you really would want to avoid such inaccuracies in the rendering as that object overlapping or intersecting with your real world objects. And that is what would occur if you used GPS, whose error could be meters and even dozens of meters, depending on the situation. So what we want to do is we want to acquire a centimeter, or if possible even millimeter level accuracy. And the way we want to do that is we want to use image-based localization. Essentially, techniques for that have existed even in 80s and 90s. It more or less accounts to collecting a collection of images of your scene and detecting the identical points and geometric primitives on those objects, and using that information, knowing that you observe the same point from multiple different views, to come up with a coordinate system and 3D scene resembling your real world, which you can later use to position yourself in the real world, given a new image. So the way it works is you need to snapshot your real world in advance. You need to collect images from different views and in different lighting. and use that to come up with scene representation for every possible place you want to localize in later. And you want to collect such information, preprocess it in a way that would allow you to really quickly find the scene where you're positioned in, and then match your image to the geometric primitives and things you've detected earlier. So this has two challenges mainly. First, and really the reason such techniques wasn't widely used before in the previous century is that you want your algorithm to be robust to changes in lighting and in views. And what classic algorithms did is they used some handcraft mathematics to describe points in an image, so they can match and figure out that the 2 points on two different images are really the same. And those handcrafted features weren't really invariant to perspective deformations, weren't really robust and invariant to changes in light. And when you can have the same scene in daylight and in night light. And the way we handle that currently is we use deep learning techniques so that we can train neural networks specifically crafted and trained in such a way that they produce descriptions of objects in an image that would be sort of similar on different images taken at different times and with different cameras, which would also allow you to use even lower level quality cameras. The second challenge is when you want to localize in such a large scale, as in you come into a random city in a random country, a random place on the earth, and you want to be able to localize there, get your exact position using just an image, a photo from your camera. So the challenge here is you not only need to collect this huge amount of data, you also need your algorithm. You need to be able to scale a pipeline in such a way that it dedicates the words to specifically to the nodes which know how to localize in a specific place. You want to the challenge is to scale with respect to geography, this sort of thing. I guess I should make a pause now and get to a more interactive way of talking, right? Andrei, you're muted. Andrei?
Yeah. Thanks a lot, Sergey. And yes, the challenges that Sergey is talking about is about gathering this amount of data, this giant amount of data. And the problem is that there is no company in the world except like giants, few of them, like Apple or Google, Microsoft, some of those, who are able to gather this amount of data and to make a large, giant database. And in fact, they are doing it right now. They started it with, for example, Google uses Google Street View images for this purpose. And different companies use different approaches and techniques, but they all do it. And they compete with each other. But there are so many companies with so incredible people working in those companies, and they are not able to get in this process because they simply don't have enough resources for that, and not a single company does. And what we found as a solution for this problem is, and blockchain helped us a lot. It is crowdsourcing, gathering this data with the help of community. And how do we motivate those people? Because we have to gather like incredible amount of data from all over the world, not only in the cities, from the cities, but from also every single space on the Earth. If we want augmented reality to work in any single space of the Earth, and we definitely do. And how do we motivate those people? Well, first of all, we have idea of sharing the results of this work to the people who do it with us. So we create and we followed with idea of private property for augmented reality. So we've divided the Earth for like squares, 50 by 50 meters, like 2,500 meters. Uh, and we call it space, like spaces of spheroid universe, and we reward community with those spaces, so they are able to first collect the data for those spaces and then later to monetize it. So when a developer when any developer will want to use and create some augmented reality game, for example, or something that will need to have high accuracy, they will have like several options. The first option is to use clouds that IT giants create, like Apple, Google, as I already mentioned those. And another idea is that they can create it by their own, with a collaboration, uh, in a collaboration with the companies from all over the world. They can create apps and they can connect to the Spheroid Earth project that unites those developers and people for creating this giant visual database and sharing its results, its financial results. And so to make it possible, we've created a programming language that is called Spheroid script and instruments for developers. And I would like Alexei to follow the discussion and to present those in some details. Alexei?
Thank you, Andrew. Hello, all. So I would like to show you our solution that aims to solve all the problems that mentioned before, including visual positioning, including gathering the data, big data, and others. So we've built our own platform with a lot of tools helping the third-party developers to create their own AR products. So all these tools are the part of our ecosystem, which involves not just developers, but general users who use the AR products that built by the third-party developers. So our ecosystem is the platform that can help to gather all the data. This data is the visual data, and our computer vision engine that solves the positioning problem uses this big data. And to do that, we need a lot of AR products that users should be interested in using the app, should be interested to gather the data, and that requires to create an interesting XR experience. One company, one developer, or one team couldn't do so many rich experiences to involve a lot of people. That's how our platform can solve this. So we've also built our programming language to firstly simplify the development process of AR product. It's really easy and faster to create AR, any kind of AR project. And we've built a lot of tools that simplifies the development. It's an integrated development environment for developers. This environment just in the browser, the developers should not have powerful hardware to install complicated software. Already there, already in the browser. It's simple, it's easy. So also we've built a 3D editor to help artists to create their installation in AR, and to help put particular objects into specific locations accurately. So also our ecosystem allows the developers run their products inside our ecosystem or create their own white label applications by their own brands. So our ecosystem has the application for iOS and Android, and if in future will be a lot of platforms for different kind of AR devices like glasses or something else. We actually are expecting that there will be a lot of devices, a lot of platforms, not just iOS and Android. And one of the interesting character or feature of our platform is cross-platform feature, which means that a third-party developer can develop his or her product using the our programming language, which is Spheroid script, and this product will be able to run on any devices and any AR devices and on any platforms. So another interesting feature for AR and XR experience is multiplayer experience, which means when one user can interact in the shared AR environment with another players, interact with them, and communicate with them, and build the AR games like, for example, shooters or quests or anything else. And this theme, this topic is closer to game development. And in game development, there is one of the most important problem on the backend side, on the cloud. The most important problem is high load, the decentralization, and so this cloud should be reliable, scalable. Because when people interact between each other in real time, there is a lot of data, a lot of real-time streaming data should be communicated between them. And we solve this problem as well, and give our developers a lot of frameworks, a lot of libraries to significantly simplify and simplify the development process. So the other interesting feature of our product is energy consumption. So if we use alternative cross-platform solutions like popular solutions like Unity 3D or Unreal Engine, it's good platforms. But if you start the AR projects using them, you can see that your battery energy goes down quickly. And that is a problem because mobile devices has no powerful hardware abilities rather than desktop devices or laptops. So, which means to use another approach, which called mobile first approach, which aims to solve energy problem. And our iOS application and Android application, where all the AR products running, these our applications are very energy efficient, that allows end users play a long time. So the last interesting thing of our platform is API. We've built rich API that allows to communicate between the app of the third-party developer and our platform. Also, this API allows to interact between products of different developers. And this leads to grow our ecosystem when a new developer shouldn't create their own, shouldn't solve all the problems because in our ecosystem there will be a lot of developers with a lot of libraries, which will be enough to solve any kind of AR experience problems in short term. So, and one of the most interesting API, part of our API, is the API to Spheroid Earth project. This API allows the developers who create their own AR projects to upload the visual data that will be gathered by the end users into our cloud to process this visual data And finally, that's how the visual positioning will be solved. Let me summarize it. So to solve completely the visual positioning problem, we need a lot of data, a lot of visual data. We need a powerful decentralized cloud. We need a lot of users who should be motivated to play games or AR products. And to solve this challenge, we need a lot of developers who will create a lot of AR products inside our platform. And that's how we are going to solve the visual positioning problem. Andrew?
Yeah, thank you, Alexei. I would like to add something, add some context to the discussion. So maybe for those who just joined us, the visual positioning system is like a big, huge machine. There is a lot of things to be done to make it work, and the main part of this system is data, a huge amount of data. And how do we create it? How do we gather it? We need a lot of people from all over the world and developers from all over the world to create apps that users will use to get this data. And it means that we have to create another big part of the project, like powerful tools to be competitive enough to compete with the something that is also standard in our development, like Unity or Unreal Engine, and we compete a lot. And we believe, and you can test, and we welcome you to test and to join us. We believe we've made outstanding programming language that make possible creating apps that are powerful enough, that are do not use a lot of battery. We are creating an ecosystem that help our participants and developers to simplify and speed up the development process. And that is all needed to create this XR cloud, to create this visual data. So we like to solve this problem, we have to solve another one, which is quite as big. And since we have a lot of tasks and a lot of things to solve, we welcome the developers who are interested to join our team, who are interested to join our work, and to collaborate with us, to ask us to develop the tools they need in their work, so we will be able to develop it based on your requirements. And we are welcoming developers to collaborate on creating open shared XR cloud that we will monetize all together with and we'll create it. So yeah, we started from visual positioning, and we have to describe and to dive a little bit in details with the different parts of our work. And yeah, that is what we do. That is how visual positioning works. So for the artist, how it will work. So in the end, at its release, and the first version of Spheroid is going to be released. Sergey, do we wait it for? It's approximately the second quarter of this year, right? So the first version.
Yeah, I would think so.
Yeah, will do. We hope so. And this will be the start of the process of gathering this data, which blockchain helps us a lot. Because again, we use private property for augmented reality to reward the developers and community with it. And blockchain helps us with it because every space is a NFT token on Ethereum, which can be acquired, sold, etc. So the final result of visual positioning system will be the web browser instrument that will help an artist or a developer or game developer or an advertiser to place virtual objects in the particular space and to view it remotely from any place of the earth, and to place it also on any place of the earth and to see how it looks, and to see and to change and to make some adjustments remotely, and then press place button and bumps, it's there. So yeah, and again, first version we are going to launch on this year, and hope we do it second quarter of this year. Yeah, so that is it. Jessica, would you like to join us and to talk a little about the open call for the artists that were made and the results that we received? Yeah.
Yes, I'm excited to talk about that because I think what we did received a lot of attention. So, with the Spheroid Universe team, after we started working with Voxel Bridge, we developed this friendship, I would say.
Yeah, it is.
Yeah, and then I think we just see the potential of working together, that it's beneficial for all of us. It's beneficial for the Spheroid Universe team because obviously we bring traction to the project, and it's beneficial for the art community because the know-how, the knowledge that you have, it's of extreme value. So I see this collaboration with you as very successful. So when I was invited to put together ETH Denver Makerspace for the fourth time, because ETH Denver started in 2015, and I started with them then, and we created a space that we called the Makerspace to bring together projects working with blockchain and to bring artists and to bring developers to join the space and sort of hack art. And this is the first time that we go virtual, but when we were doing the makerspace in the physical space, it was really interesting because we would see projects bringing drones, projects bringing hardware and software integrations, and artists who are interested in light and sound, and nobody really knew what they were going to do. But then once at the hackathon, just like all the pieces started getting together. And so when I see that Andre, I'm sorry, is
Andrew's fine.
they're welcoming people to their team, they're welcoming artists, they're open to collaboration. I think it falls right in line with the ethos of the makerspace and the ethos of ETH Denver as a hackathon. So I expect that maybe some hackers from ETH Denver or developers in blockchain are seeing this, who are maybe putting together a project for a bounty, and maybe their research or their project fits in within the technology that you have. Then I would just encourage you to reach out to the team. Where can people reach you, Andre? Just to give you a shout out on like your contact.
We have our website and the Telegram group over there, so feel free to join it. Feel free to ask questions and to share the ideas of collaboration. We are there. We are in discussion always, and also you could write on Twitter, on our Twitter, and we respond. Yeah.
Sorry to interrupt you. Spheroiduniverse.io.
.io. That's it. Yeah.
Exactly. So yes, that being said, getting back to the open call, the open call falls also in line with that collaborative nature, to get artists who already have a certain knowledge of 3D rendering, creating three-dimensional objects, who perhaps have never tried showing their art on virtual reality, on augmented reality. So it's like providing that bridge between you guys and the artists. So we received about, I think I would say something like, I don't know, 20, 17.
Yeah, something like 20, yeah.
And it was really incredible to see your team work with the artists by the hand, walking them. This is what you need to do. This is it. So for those of the artists who took advantage of this opportunity, I'm sure they're very happy to see the results, because they're really outstanding. And I hope, that you continue contributing to the art community. Maybe we can in the future elaborate more.
Definitely.
Myself and you guys are already working on the voxel bridge, which is a big undertaking. So you, the audience, will be seeing some of those results coming up soon. And I guess for the magazine, because the Spheroid universe is also putting together their first edition of a magazine about augmented reality and art, which is called AR.
Art Monitor.
What?
AR Art Monitor.
Art Monitor. Yeah.
That's it.
Art Monitor. And so this exhibition with the 10 artists that we selected, let me share the image actually, is displayed in different cities, as you saw with the Giga objects, but they're also part of the magazine. And so I was happy to invite the artists to apply. I was very excited to see the submissions and make a selection of the 10 artists. In my selection, I kept in mind kind of what I saw to be the common denominator of the art, which was like approaches to sort of fantastical shapes, fantastical figures, things that were not really trying to resemble reality, but kind of going more sort of in the side of imagination. Try to make a selection of works that were all sort of in that same line. And then I also wrote curatorial brief text, and I called the exhibition, I call it Breaking the Screen, because I see that the virtual reality object sort of breaks that monotony that we have been seeing with experiencing digital art through our flat screens. And even though you still need a screen to view the object, you have a more physical relationship with this sort of illusion, So the fact that your body becomes part of the experience, even though you're still using a screen, you are breaking that barrier between the two-dimensionality of the screen and that sort of monotony that I see sometimes with digital art, that sometimes it gets kind of boring because it's all on the screen, and we're on our screen so much that it's almost like we need to get out of it. So the exhibition is called Breaking the Screen, and it sort of addresses that break that is happening between digital art living in the computer and its new relationship with the body. So excited to see all the pieces. We have some examples that we shared already. We saw it on geolocation. We saw this one, and I think we saw another version of this one. But I guess, and I think this one was also there. It was a really great experience. Thank you for facilitating your expertise.
And thank you for your work and for all the stuff that was done to make it possible. And we'll definitely share the link soon for the AR magazine for its web version.
Mhm.
We have launched augmented reality version of this magazine in XR Hub, which you can download on Play Market.
Mhm.
And also we are aimed to continue it, and we hope we can collaborate a lot in the future regarding it. So it was
Mhm.
very interesting project for us. It is a very interesting project for us too. Yeah.
Uh-huh. Well, excellent. Thank you so much for participating. We unfortunately have run out of time. But for those of you who are watching and want to talk to the team, feel free to jump into the Gamer Jive, the ETH Denver virtual space. Some of the team members will be there in avatar form.
Yeah.
They'll be able to answer questions. If you are not able to do that, feel free to reach out to them, spheroiduniverse.io. And thank you again. You guys have a great rest of your day. And congratulations on
Thank you.
an awesome job. You're fantastic.
Thank you, Jessica. Thanks a lot.
Thank you,
Thank
Jessica.
you. Yeah, thank you.
Okay.
Bye bye.
Very
Bye.
nice.
Bye bye.
Thanks.